My name is Ilya. I'm working for DataGrid. We make an PostgreSQL consultancy, and I have some sort of a hobby. I collect in the things which people do screw up, because the problem is very simple. Best practices are just boring because, if just imagine I stand here and tell you, do this, do that. That would be not very funny because probably you know that better than me and still do some strange things. So I try to present it like in more fun manner, in something like stand-up, sort of database stand-up. Only worst practices can really screw things up, and you will have a great opportunity to remember them in 10 years and say, I did that. And besides of them, if you follow worst practices, I really sometimes think many people follow my talks, just forgetting about let's talk about worst practices. PostgreSQL consultants are nice people. You probably saw them at last session. They like people who follow worst practices. So let's figure out how it works. I have a list. It's some sort of a repository, like more than 100 worst practices. It's separate slides. Right before the session, I just reshuffle those examples, of course with a Perl script, because you do not write the script for worst practices talk in Rust or in Python. I thought to rewrite in Perl 6, but it looks like it's never existed. Some things from this list I like more or less, and some of them are actually normally come together. So as a not very good practice, I take a look on this automated thing and then add something manually. But please forgive me for that. So let's start with a very easy test environment. And forgive me if I would be like telling something strange things, because I just reshuffled that. I did not read this. It's also a good worst practice. So example 0, it's just example to learn how it works. Do not use indexes. Basically, there is no differences between sequential scan and scan by the index. You can try and see. You just very simple prove it. Just insert 10 rows, run, explain, analyze, and you will see that sequential scan would be probably faster. Point proved. So follow this worst practice, it's very good. And of course, nobody run into more than 10 rows in production. Did you ever see more than 10 rows in production? I never saw. Another easy example. Do not allow developers access production database. Because, what useful they can do there? Not even read-only, not even their team lead, security first. That's really win-win situation. Your developers would run the code in production, never seen the production, and they would blame DBAs and admins. It's great for company spirit, actually, And DBA would be responsible for that. He would be very nice person towards the developers. So what can possibly go wrong? Well, let's start with the proper ones. So real world ORMs. Use ORM because all the databases share the same syntaxes. It's SQL, for God's sake. You must write database independent code because every one of us usually works in the project today with Oracle. After lunch, we work with MySQL. When in the evening, we migrate to DB2. And so we need to be database independent. Some old school people are constantly telling that some database have some specific dialect things which allows to improve your query performance. That's not true, don't believe them. Just use an ORM. And besides of that, any natural ORM is a complicated technology. You can learn it for years and then put it into your CV. I'm like magician about Hibernate or Active Record or whatever. So do that. It's a very nice thing. Use as many count as you can, because count is very nice SQL function. This figure is very informative if you put this figure on the main page of your website and you have a load, and user will refresh and get another one which probably slightly different from the previous one. It's very informative. And of course select count is very inexpensive function. It never performs full sequential scan. And well, estimated figures like this, they are not informative enough. You need to have a real information. So use as many counts as you can. One of my favorite actually, I try to just pin it to every presentation. Move joins to your application. Yeah. Huh? Yeah, just. You probably can guess what is behind there. Yeah? Thank you. Just select a couple of tables, put into your application. The important thing is should be programming language you enjoy, because however you can do that in programming language if you not like programming language. I became DBA because I don't like to program. Then you join them at application level, and that's great thing. Now follow few simple steps. Now you need to implement nested loop join, hash join, merge join, and some stupid thing called query optimizer on page cache. So after that accomplished, you will be an author of a new database. That's yay, that's very good. Be in trend, be schemaless. I don't know if its trend is still existent, but from time to time I run into it. Yeah, NoSQL, schemaless, etc. You do not need to design the schema because, well, schema is boring constraint on your imagination. You only need one table, 2 columns, ID big 0 or big int, and extra or meta in JSONB, or if you want to be enterprise in XML. JSONB data type is pretty effective in PostgreSQL. You can query like normal thing. Even if you put 100 megs of millions lines of JSON in it, even if you have like thousands TPS, it's very efficient. Believe me, use it. It would be very nice. You know, what can possibly go wrong? But you can use actually different approach, which is much more enterprise and much more common from my point of view. You only need 3 tables: entity, attribute, and value, because you know you need to be like universal. At some point, add the 4th, attribute type, because you know languages with typization, it's actually some sort of constraints on your imagination. So you follow me, yeah? So attribute type, and at some point you need to improve the schema, because then it starts slowing down. You need to rename this into the core or the kernel of the system and add lots of tables to denormalize the things to let it work. So it already sounds like a good technical plan for like 20 years of development. Do it. And if it's not enough, based on your reaction, I feel that you did this. So it's basically everyone who saw a huge warehouse actually saw this. So, well, now you see how it works. Maybe I did not need to include any test examples. So it's like, you need to feel it. Try to create as many indexes as you can. Forget about the example, yeah. As many as you can. You see, there is no extra disk space consumed. Indexes consume no shared buffers. There is no overhead on inserting something or creating, adding a new column or things like this. Optimizer automatically will choose the indexes you created because you are a boss here. Optimizer is some sort of like service person. Keep calm, create more indexes. That's a good approach. Even if you want to back up your database, well, I would say it's already too good practice. You can use replication instead of backup. And then someone deletes something. You probably could switch over. And, well, it doesn't help. So it's proper worst practice, yeah. Well, it depends. Well, basically, if you do not use any backup, you're even more GDPR compliant. So, you see, you get how it works. You can use pgdump instead of backup. That guarantee that you lose some data between dumps, so it's basically, it's already bad practice. You can write your own backup script, because if you take something existent, probably someone took a look there and had problems and reported a bug, and it was fixed, and you would not run into it. So basically write your own, it's a good idea. Backup should be as complicated as possible. Take a couple of external tools, combine them, it would be like very good. And of course, one of those tools should be very enterprise grade, like Tivoli or things like this. That would ruin things up quite properly. Never, ever run a test recovery. Because if you do that, you probably will learn that your backup is not very optimal. And never ever use pgbackrest, because it's a good backup solution. Turn auto-vacuum off. You know, auto-vacuum is a very annoying auxiliary process in PostgreSQL. It always runs, it consumes resources, so just stop it. You can actually kill it or stop it, whatever you prefer. Then you will have 100 gigabytes of data in a database which is size of 1 terabyte. And well, a lot of RAM now it's cheap, so you can easily afford that. And input-output improved drastically over the years. SSDs are also not very expensive, so keep calm, switch out to vacuum. Besides of this, you can call this big data. Nobody likes small data, maybe only I like small data. Everyone likes big data, because big data allows you to feel yourself like a boss, like a magician. Always keep all your time series data, like logs, information from some sensors or something like this. For all the time, just keep that in database. Because, you know, you always need to have a place where can you check if you run out of disk space. And it's easy method to find it. Never, never, ever delete this. And you can always call this a big data. Oh, enterprise grade. Then you can try to solve this problem with partitioning. You have all your inventory data since the beginning of Linux time, Unix time, and you just can partition that for an hour or a minute or something like more gradual, because like you need to keep a lot of data. Never, never, ever aggregate this, because it would be too efficient. And of course, Optimizer would work well with this. Reinvent Slowney. Who knows what Slowney are? Oh, so Magnus, you can skip this point. Everyone else could try to implement Slowney. just because you don't know what a nightmare is to administer Sloanie. It was before the normal replication comes to Postgres in version 9. There was the trigger-based replication called Sloanie, and it was incredibly difficult to administer. And if you reinvent Sloanie, I mean, write your own replication system in some programming language or something like this, you can run into all the problems PostgreSQL run since the times of Sloanie. So never ever use existing tool. It's like general rule of thumb. Never ever do this. Keep master and replica on different hardware. Because, you know, we like high availability. High availability is our goal when we are talking about master and replica. That will maximize the possibility that something goes wrong with your failover. Because, you know, if they are on different hardware, you had this workload on your primary, you fell back to replica, and it's like 10 times less powerful. What happens? Again, success. So let's do that. You can make things even worse. You can just touch the replica-related parameters on the replica and never ever touch the primary-related parameters like shared buffers, checkpoints, things like this. Then you perform failover. Actually, it might even be the same hardware. But when your database starts, it just cannot work with this workload because shared buffers are different, checkpoints are different, everything looks like non-optimized. So then it is a critical moment, you perform a failover, you have plenty of time and you are calm to make those changes on the fly. So let's do that. Another good idea is actually to use for high availability synchronous replica because, you know, if it's synchronous, it's high available, it's automatically. So it's a good worst practice because then something goes wrong on the replica, you just lose entire cluster. That's very efficient. But you actually can put that in the remote data center because, for example, if you have one server in US and one in Europe or just on different coast of US, there is magical network between them. There is no delays. You probably know this. Yes, no latency. Latency, it's like for very boring people. So it's, just do that. That will maximize availability. And our continent is just like 100% guarantee. Never ever use foreign keys. Because, you know, consistency control, it's like probably 5 to 10 times a week. I see that when people talk to me, we are trying to keep consistency in our application. And regularly you find something like now there should not be now, something very funny things like undef from Perl code and the application is 10 years in Java and used to be in Perl 10 years ago or something like this. So consistency, all this works good in application. And well, you know, database is a framework which allows you transactionally keep consistency. It's a special tool designed for that, in case of Postgres, for more than 20 years. Why are you supposed to use that to keep consistency? You have your application. Just don't use special tool. If you want to I don't know, to crash your concrete wall, use your iPhone. It's like tool for a purpose. Just do that. Always use text type for all the columns because, you know, text type is very universal. You can put a figure there, IP address, things like this. And implement some sort of consistency validation inside your code, preferably using regular expressions or something like this. And if you don't do this, you never ever will see things like this or like that. So once again, data types are the thing which designed to help you. It's specially designed for that. If it's specially designed, you remember what to do, don't use it. Always use improved versions of PostgreSQL. So, you know, Postgres is not perfect database. It's open source, for God's sake. And lacks of marketing, so we know that it's not perfect. You are smart. You can overrun some annoying things about MVCC, about 32 bits transactions. You can improve that in a different way. Hack it, apply this patch, don't bother to submit it to the community. Never ever do that, because, you know, if you submit patch to the community, some annoying person like this one or that one shows up and say, that wouldn't work. You don't want this, it's not interesting. So just apply your patch, put it in production, and in a year or two of working with this Postgres, you only need to apply another like 500 merge things, and you will be okay. Back into a community version, it would be very good. So you see, just do that. Postgres, remember, Postgres likes long transactions as any other database. Always call external services from the stored procedure, because stored procedure is wrapped into transactions, like sending email or calling another service and something like this. But, well, you can tell me that probably, well, that's a good practice, we do that. That's arguable, so sometimes it's nice to have this functionality. I would say that it is a good thing if the person who implements that open the web store dictionary and say what timeout it is. That's the second part many people are actually missing. Anyway, you could just start transaction and go away for a weekend. At least your colleagues would know who to blame if something goes wrong. And, well, it's actually a good idea to do that, especially during a weekend, because your weekend probably could be ruined. So it's a proper worst practice. Test-driven development first. Write SQL query. Remember, test it only on your laptop, preferably inside virtual machine or something like this, or inside Docker container or something like this. 10 rows, you remember 10 rows is very good, so it would be work perfect. And in production it would be never 10 rows, so do that. If you have problems with your PostgreSQL installation, like something unfixable, too monolithic, lots of stupid code, doesn't work, performance problems, there is a silver bullet. Just move those problems to the container. Because you see, if you move something to the container, magic happens. And with microservices, nothing gets wrong, because you have a monolith and difficult to do with something. You move part of the monolith into containers, and now you have monolith of containers. You see, that works well. It's always good, besides of those things, it's always good to have something made with idea of persistency, durability in mind, inside something which actually very unstable like containers are. I always suggest actually a very simple sort of mental exercise about containers and microservices and database systems. Just imagine we substitute word container with Debian package. So you have your database. You just pack it inside Debian package and deploy it like Debian package. Does anything changed? You have some extra work to pack it into Debian package. Nothing actually changed. The same thing generally with containers. It's sort of like Debian packages for modern DevOps. So just do that. And now you have problems both inside and outside. Your database needs to work inside container, and it needs to interact between containers. So win-win situation. Not only Solani should be reinvented. You probably would be laughing, but I really saw that. Need to convert timestamp stored procedure in C with case switch will help you. It's like very easy. You never will forget to like create it, not forget to deploy the shared library. Just do that. Need a message queue, write it in SQL. There would be no race conditions. I probably saw like 80 of them and wrote 2 of them. So it always works good. So just do it. There are tools for that. Don't use them. Want to use ORM. You already think that ORM is bad thing, yes? So write your own. The good thing is actually to construct queries in PostgreSQL. It would be like very efficient. It's interpretable language. It's very fast about concatenating strings, and you have no problems with troubleshooting those things when it comes to troubles. Never use exceptions. You know, PostgreSQL has a single piece of documentation, which, from my opinion, every software developer read once. It says, like in some frame, that exceptions are slow. I wonder if people will read so carefully any other parts of the PostgreSQL documentation. I would be like without my job and will do something else then. But somehow they read only this part of documentation. So raise notation errors, because you know everyone monitors log constantly, or better actually suppress them. It's a very good practice. So like a couple of days ago, there was a beautiful thing that people using some backup tool, they took some mainstream backup tool, improved it slightly, and were making backups. But as I told you, they were following my worst practices. They never tested the recovery, so they do not suspect that this backup is unusable. But in the logs, it was clear state that like buffer full, things like this, we stop, exit, core dump, things like this. So nobody takes a look on the logs. Just suppress the errors and that would work. Application runs out of the connections. Probably you experienced that before. It's quite a common problem. Set max connections to 1000. Because by default it's like something 100 something that's not very big. Servers with 1000 CPUs are quite cheap now and very common, and Postgres is scalable to those figures. So just do that. If you run out of those connections, you can do that 2000 and 3000 and even more. So more workers, more efficiency, no overhead. Just do this. Never ever use a tool called pgbalancer, because pgbalancer is a special tool made to deal with this situation. You remember, you don't need to use that. Always use timestamp without time zone. Because you are laughing, I see that pretty much every month. Your application will never work in different time zones, and your customers would never connect to your application in different time zones. And actually, you know, timestamp without time zone, it's like normal thing, so it's like we constantly deal with that.
Well, this is America.
Yeah, well, I know a couple of other countries who do the same, so it's not only America. If someone asks you why you do this, you have an answer ready. You want to save on storing the data. So if you answer like this, you look smart, and people go, oh, they really know, they really knew the data, so basically they invest some efforts to protect the things. If you need a time zone finally, just add a separate begin column. Don't add int4, because int4 you can run out of int4s and on time zones. Then you end up with time zones like null, 66, undef, -1, or something like this. Add constraints and checks. Or better, write a custom data type. Because timestamp with time zone is the proper thing to handle those things. Just do like this. Always start tuning PostgreSQL from things like optimizer options or genetic optimization or things like this in PostgreSQL conf, because it's really affect your queries. And never ever try to touch shared buffers, checkpoints, and things like this. They are some auxiliary non-important parameters, you don't touch them. So first things first optimizer. Yeah, as I told, that's a good first candidate. It changed the performance thing quite dramatically. If you have heard about new cool feature, use it in production immediately. You see, it's a good approach. Attend MVCC Unmarked talk by Bruce Momjan and find it on YouTube. He explains quite good lots of internals how MVCC concurrency control model works in Postgres. Looks very complicated, very mathematical, cool feature. Learn about xmin and xmax. You can actually do that simply if you run select query from any table in your Postgres and add some columns xmin and xmax, there would be figures there, probably. So you can learn what it is as homework and use that in your application logic immediately. Nothing can go wrong, just do that. Another good alternative example, since version 11, we have a cool stored procedures with full control of transactions. So you can use begin commit like in Oracle days, which brought lots of money to Oracle consultants. Now we want our piece of cake. Just use as much begin and commits inside of transaction together with complicated logic, with if, else, things like this, operation structures, and everything would be good. Have fun, and avoid rollbacks for best results. You know, if you don't use rollback, preferably forgive about rollback, because your transactions is always a successful thing. So don't do this. Never ever use a graphical monitoring. Because who needs graphs? It's easy task to guess what happened in 2 a.m. yesterday if you just log into the server, open top, and just imagine what could be going on 2 hours ago, 6 hours ago, or something like this. Because your graphical monitoring allows you to control the trend. It's too good practice for you, so just don't control the trend. Load your data to PostgreSQL in a smart manner. Write your own loader, preferably in Java, preferably in parallel, because you know parallel is faster, and lots of threads, it's like very efficient. And never ever use copy, because you remember copy is specially designed for this task. If something is specially designed for this task in Postgres, don't use it. And don't forget, that was worst practice talk. Because sometimes I feel that people just making photos and just forget which talk they attended and then mix them up and go and use them in production. If you have something favorite, just send it to me. I will include that, and we spread bad knowledge into the masses. Thank you. And I think we have like a couple minutes to questions. Yeah.
Use CQRS and event sourcing to create your architecture.
Oh yes, and auto-generated schemas. You draw that with some graphical model designing tool, then generate schema. It will be very good. Questions? Yeah.
You mentioned PG backups, and I asked this as better practice. Do you recommend things from single queries, like Bowman, things like that?
Yeah, well, those tools are quite usable. So basically, there are several tools on market. From my point of view, Barman has a benefit that it's quite old. That means stable. But Backrest has different strong points from my point of view. It's designed to use like more enterprise approach towards the backups. I mean, differential backups, more possibilities to work with. And another thing is, which I personally appreciate, PG Backrest team makes a lot of effort to bring it into the core, which is slightly more perspective from my point of view. So both tools are good, as well as actually PG-based backup, which is not that fancy and with those bells and whistles, but still quite usable and quite conservative. But well, it depends on things you need. Yeah, well, you can screw built-in backup in many ways. General approach to screw up built-in backup is use rsync script, which you write instead of PG-based backup. I failed to do that a couple of times myself, so I can recommend this.
Can I extend the question answers or replication? You may thought about Sony, you think about web manager, about single query, or other.
Replication managers, it's like, generally it's several slides in this talk, just not reshuffled them. You know, the main idea to use replication managers to simplify things. But at the same time, you add extra layer, which is some complexity, which is not very good. In those terms, I would say that if you use Rep Manager or if you use Patroni, that's probably the best solutions to do this because they are widespread, quite stable. Maybe Stallone is there as well, but it's I personally prefer to use Patroni and then probably Rep Manager. But it's about my convenience. Important thing is that most people trying to use replication managers to get more high availability through autofailover. And to be completely honest, sometimes it's worse practice itself because we try to minimize downtime. And then we're trying to minimize downtime. We actually estimate some average downtime per year or something like this. And theoretically, with autofailover, we get like few seconds of downtime. But if something goes wrong, we exceed this budget for downtime for years because if something goes wrong, we can go down like for many, many hours because of autofailover.
Right. So let's write running concepts with PostgreSQL tools, with Ansible or manual coffee.
Yeah, well, I would say that manual switchover is not that difficult. So it's very, very basic functionality.
You're writing it around something that...
Yes, yes. Yeah, so basically you can experience everything on your own. To be completely honest, to use Rep Manager or to use Patroni, there are certain things to screw up there as well, because they are quite complex, especially Patroni is just a very nice tool, but it's like, it's the tool to orchestrate several different tools, and something can go wrong there.
So going manual or somehow using DevOps tools to do that is still like a thing?
Yeah, it depends on your task, I would say. It depends on your task and how good you are in writing those tools. Yeah, Patroni is probably the most easy tool to not shoot your leg. You probably can shoot another leg, but well.
I have a question about the ORM. How do you deal with the developers who are like, well, they have a J-code application and they're using ORM, you know, you're like, well, make sure that you have the right foreign keys and stuff. Usually it's not so bad, you need the ORM. But how do you go telling the developers that it's all right to go and write a bit more database-specific code so that it's actually more efficient?
Yeah, general approach that I like, it's sometimes it's impossible to use, but it's like good advice to use that inside the team. You have beautiful extension, pgstat statements, and you can add very simple tool. We actually have it on our GitHub, which makes some sorts of the pgstat statements, and once a day it sends email to your team with top 10 or 20 or something like this slow queries. And that's the first stage. So basically you send those slow queries and everyone, including team lead, all developers receive this and see, my query is now in top. Why? As a DBA, you can explain why. And people are supposed to listen to that. And sometimes it's also a good idea to do some drastical things because, for example, if you have heavy loaded web application and you have top queries like 100 seconds or something like this, or even milliseconds, it's not good. So basically that means you lost this user from the web interface because nobody will wait for that time. So just people go away to your competitor. In this case, we actually put the cron job, which just kills every query which exceeds this limit. Yeah, and that's the first part. The second part, much more important, that if it happens, everyone gets the same email that this query was killed. Like in a week, it would be fixed. Believe me.
Yeah, let's suppose that you have somehow the high ground with your developers.
Anyway, you need this, because then your DBA team and developers live like in test environment, everything works, and it's your database stuff, just push that red button and make everything fast. It never ends well. It's never ends well.
I was going to ask, what if they try to make it to the top 10, but killing the core is probably a good way to do it.
Yeah, because, important thing is like sending those emails, because then everyone in team sees that my query is screwed up, I need to fix it, and it's obvious for everyone. So it's like a proper way to do this. Yeah.
All those were really great, but I didn't understand the ORM because what I told the people on my teams and stuff is that not using an ORM is a worse practice.
Yeah.
Just write directly to the database.
Well, it's actually, it depends. I would say that healthy idea is if you really need to develop your product fast, not telling about application, the product. You probably can make this choice quite deliberately. So basically, if you need to program something fast, you just use ORM, then you take a look on the pg-start statements and see how it goes. If you have very stupid queries on top, you probably fix them by writing them in native SQL, and everything else you keep in your ORM because it gives you a benefit to develop the things faster. So that's the proper approach, I would say.
Like with Java Spring, which I think is a really common framework, I couldn't imagine not using Hibernate.
Yeah, well, if you're using the framework which is actually designed to be used entirely with ORM, you probably have no choice because it's quite inconvenient to use native queries there. But for example, in things like GDBC templates or things like this, it's quite easy to use native things. So it just depends what part of this thing is more important for you. At some point, you need to figure out that actually developing product faster, it's faster only up to a certain moment, because after that you need to maintain this product. And then it's sometimes quite easier to fix native queries, not the ORM, then it's like very complicated and you need to do some things which should work fast. So
So does your ORM has some ability to bypass the basic ORM thing to use extended features?
Yeah, actually, but actually you need to learn another technology, because if you take a look on Django, for example, if you use Django ORM improperly, you can really screw things up. You get the transaction which never committed and so on and so on. So you need to really learn how that works. And another good comparison is clouds. So it's really convenient to use clouds. Then you don't need how to scale the things, etc., etc., etc. You just have a good pattern. You can scale that very transparently and so on and so on. Then you hit intensive load. Then your project became popular or something like this. Your price goes like this, and quality doesn't grow the same speed. And then you probably need to think how to scale properly, what to migrate to bare metal, what to leave on the cloud, etc. It's pretty much the same thing. You always trade convenience against performance. And sometimes it's actually better to choose convenience, because in terms of getting better performance, you can spend like many years and be run out of business. So I think it's time for a next talk. Thank you.